Welcome back to the sleepy universe. Tonight, you drift toward a world you can't see, one made of opposites, reflections, and vanishing things, antimatter. It sounds like science fiction, but it's as real as your heartbeat, as silent as the dark between stars. In this story, you will float gently through the strange mirror of reality, where every particle you know has a twin, and everything you are could have quietly not been. So settle in, breathe slowly, let the laws of physics unravel softly in your mind. We're not here to solve anything, just to fall gently into the beauty of what might have disappeared. Close your eyes and imagine the softest silence imaginable, not the kind that follows a distant thunder, not the quiet after a song has ended, but something far deeper, a silence before time began, before there were stars, before gravity pulled, before any light scattered across space. No echoes yet, no distance for sound to travel, because there was no space. And yet, within that silence, something poised itself on the edge of becoming. A balance so perfect it required no correction. Not yet. Not until the stillness cracked in this pause before the universe. There existed a strange, potential attention waiting to breathe. A single breath had not yet been taken, but already the possibility of breath stirred. This was the beginning, not of matter, but of possibility, of symmetry, of pairs so precisely matched they could cancel each other out without a trace. One was matter, the other was its twin, antimatter. Born not in opposition, but in equal embrace, not enemies, not opposites in battle, just reflections in a mirror. Neither had yet stepped through. The laws that would one day govern everything had not yet spoken aloud, but their whispers already moved. The universe would follow rules of conservation and balance, charge, mass, energy, but in this quiet origin, it seemed as though those rules had only one command: let nothing be left unpaired. And so, when an electron appeared in this infant cosmos, a positron was born with its mirror opposite, same mass, but with a reverse electric charge. When a proton came into being, so too did an antiproton. Neutrons, antineutrons, quarks and antiquarks. Everything doubled, and the cosmos was still nothing, because the positive and the negative cancelled out. Every birth came with a death. Every something met its unmaking, and yet the dance began. This beginning wasn't like the flash of fireworks or the stroke of a match in darkness. It was more like a ripple spreading across an invisible ocean, impossibly wide. The Big Bang wasn't an explosion in space, but an explosion of space stretching, unfolding, expanding with sudden hunger for itself. Time didn't begin at the tick of a clock, but as a property of this unfolding, this dynamic stretching. And within that stretch, particles blinked into existence, always in pairs, always perfectly matched. You might imagine them like dancers, stepping onto a stage at once, circling one another in patterns we could barely hope to follow. They never touched, not in the way you think, but their presences were woven together like melody and harmony. And then, when they did meet, when matter and antimatter collided, their dance ended in light. Not silence, but transformation, pure energy. Two opposites erasing each other not into nothing, but into brilliance. And so, across the young cosmos, the first great light began not from stars, but from annihilation, from the intimate disappearance of matched pairs. And this light, radiation born of mutual erasure, flooded everything. The universe was not yet transparent, not yet cool enough for atoms to form, but it glowed with the memory of this great balancing. It glowed with the cost of perfect symmetry. You lie back in your thoughts now, imagining this place, the great beginning. But the truth is, if things had stayed symmetrical, if every particle of matter had found its antimatter twin and kissed it into oblivion, there would be nothing left. No stars, no planets, no breath, no breath, no you. Just a cold, dim wash of radiation. A perfect silence again. So what happened? Somehow the balance failed, or rather, it leaned just slightly toward matter. Out of every billion pairs, one particle of matter survived unpaired. Just one, and that tiny imperfection so slight. It almost didn't matter is the reason anything matters at all. That sliver of imbalance is the reason you are here, the reason galaxies spun into being, the reason thought bloomed in brains that came billions of years later. That imperfection is the seed of every story. Physicists call this the asymmetry, a phrase that sounds simple, maybe even boring, but inside it hides the most fragile and beautiful truth. That perfection, left unchallenged, would have erased all meaning. That it is the failure of symmetry, the fall from balance that gave rise to time and structure and consciousness. The universe, in a way, began with a tiny mistake. And that mistake was everything. Somewhere in that early moment, unknown, processes tipped the scales, maybe through interactions with other fields, maybe through random quantum fluctuations, maybe through rules we haven't yet found. But when the last wave of annihilation faded, when the blinding wash of energy cooled, matter remained, just a breath's worth, just enough, and so the silence was broken, not by perfection, but by the echo of imbalance. And that echo became stars, which lit up the dark. It became gravity, which sculpted matter into galaxies, which gathered gas into clouds, which collapsed into fire. It became carbon and water and slow chemistry. It became DNA. It became thought. Now, as you lie in bed, you are floating in the far echo of that event. The particles that make up your body, your bones, your thoughts, your breath are made of that leftover matter. You are built from the imbalance. And somewhere, perhaps, a matching antimatter universe might have been a twin you'll never meet, erased in the earliest light. Or maybe it still exists, hidden beyond what we can see, shaped by opposite rules, moving in reverse. Remembering a different version of the same silence, you begin to understand now why the story of antimatter is not one of destruction, but of absence. Not of enemies, but of mirrors. The universe carries this wound of lost symmetry gently, like a memory of a dance that could have gone differently. And in that memory is a quiet kind of poetry. What if that balance had held? What if everything had truly cancelled out? Would there have been peace? Would there have been silence? Or would the universe have sighed and tried again, waiting for just the right flaw to make it sing? The thought lingers in your mind as you sink deeper into rest, that what we see now, the stars above you, the world you know, is the result of something not quite working the way it was supposed to, and that the most beautiful things can arise from a slight tilt, a soft lean away from the impossible symmetry of perfection. The antimatter is gone, mostly. Its trace remains in gamma rays, in laboratory collisions, in the calculations of physicists who still wonder where it went. It whispers through cosmic rays and flashes briefly in positrons born from thunderclouds or radioactive decay. It exists in medical scanners and particle traps, but not in the bulk of the universe. Its absence is a presence, a kind of cosmic silence that shaped the music, You begin to see the beauty in the not quite, in the almost, in the barely tilted. The universe does not demand perfection. It uses imperfection as its brushstroke. It does not erase the asymmetry, it paints galaxies with it. And as you rest now, you are not just in the universe, but of it. You are not just watching the dance, you are the result of a dance step gone gloriously offbeat, a lingering echo of a universe that could have been silence, but chose song. And in the next stillness, you wonder gently, what is antimatter, really? What was it supposed to be? What did we almost become? You lie still, your breath quiet, your thoughts unfolding like silk. Around you, the world softens into dimness, and within that dimness, a shape begins to form, not with edges or angles, but with feeling. It is a mirror, not one that reflects your face, but one that reflects your existence. Not a thing of glass, but of nature, of deep symmetry. This is where antimatter begins, not as something frightening, but as something familiar wearing its clothes inside out. Imagine, now, a single particle, an electron, tiny beyond imagining, and yet essential, a curl of negative charge wrapped around nearly no mass at all. Every breath you take relies on its motion, its orbit, its silent thread within atoms. Now picture its opposite, its twin, the positron. It is not evil, not dangerous by nature. It is simply the same particle, reversed, same mass, same spin, same rhythm, but with a positive charge. It is not here to undo the electron, though it can. It is here to echo it, to balance it, to prove that even the smallest thing can have a double. This is antimatter, a story of war, but of symmetry. For every type of particle in nature, there exists or once existed a corresponding antiparticle. The proton has its the neutron its antineutron. Quarks have antiquarks. Neutrinos may have antineutrinos. Though the details remain hazy, these partners are not inventions of theory, they are real, and we have met them, touched them, held them briefly in magnetic traps before they vanish again. But what is antimatter truly, beyond charge and name? In the stillness of this thought, you begin to feel it differently. It is a whisper from the rules that underlie everything. The universe, though vast and seemingly chaotic, is governed by deep principles, laws of conservation, symmetry, and balance. Antimatter is the answer to one of those laws, that charges must be balanced, that energy must come with its counterpoint, that for every crest in the cosmic sea there must be a trough. Antimatter is not stringent, is necessary. It is how the universe stays whole. Yet here's where the mystery lies, and perhaps the sorrow. Antimatter is almost entirely gone at the moment of the Big Bang. Matter and antimatter should have been created in equal amounts. For a fleeting instant, the universe was filled with twins, swirling and sparking, each mirrored by the other. But the symmetry did not last. As we learned in the previous chapter, for every billion pairs, one matter particle remained unbalanced. The rest collided and disappeared into light. And the positrons, the antiprotons, the antineutrons, they are now mostly gone, ghosts trailing in the wake of what could have been. What you are left with, here and now, is a world made almost entirely of matter. Still, antimatter leaves behind clues. In thunderstorms, for a moment, positrons are born. In radioactive decay, they emerge for an instant before vanishing. In particle accelerators, we summon them purposefully, smashing atoms together at near light speed, coaxing tiny sparks of antimatter from the wreckage. It is like shaking a tree and catching feathers on the windbrief, fragile and glowing. with implication. In hospitals, positrons help map the human brain. In laboratories, antihydrogen atoms are trapped and studied, held delicately by fields that cannot touch them, only contain their dance. When a positron meets an electron, both vanish, their masses transforming into pure energy to photons of gamma light. The act is called annihilation, but it is not violent. It is precise, clean. No mess, no residue. Just disappearance into radiance. You can almost see it, not an explosion, but a sigh. Two halves meeting and becoming one whole pulse of light. This process happens everywhere, in the hearts of stars, in distant galaxies. Perhaps in you, if a cosmic ray from space births a positron that finds its electron match. But you never notice. The energy is too small, too silent. Antimatter is not something that screams, it hums, and this hum has structure. Antimatter, if kept apart from matter, behaves just like matter does. A positron will spiral in a magnetic field, just as an electron does. An antipraton can form an antiatom. Antihydrogen can emit light, form bonds, drift through space. If we had enough of it, we could build anti-planets, anti-stars, anti-people. They would behave the same way as our own structures. Chemistry would function. Reactions would occur. If you touched such a person, you would both vanish, but only because you are made of matter. To them, you would be the one in reverse. And so antimatter asks you to question what is normal. It suggests that what you call real is just. What remains, that other realities were possible, perhaps still are. Maybe far away, beyond the edge of the visible universe, a bubble of antimatter survived. Maybe it formed galaxies, civilizations, consciousness, just like we did, but backward, unreachable, balanced. In this light, antimatter is no longer the villain of science fiction. It is the quiet twin, the missing half, the version that didn't win, but still whispers through the rules of physics. Scientists search for it still, building detectors that scan the sky for antiparticles, hunting for antihelium, anti-carbon, proof that larger forms of antimatter might still drift between galaxies. So far, they have found only the smallest hints, but even a trace would change everything. In sleep, this thought lingers with you, that the universe may have had another outcome, that reality might have flipped the other way, and that, in some mirror of time, your reflection walks under stars made of anti-light, dreaming its own questions, wondering what became of you. But even without that mirror world, antimatter remains close. In every equation that governs the quantum world, the opposite is implied. The photon, the particle of light, has no antiparticle. It is its own twin, but the rest all hum with duality. Antimatter is stitched into the mathematics of how particles behave, how they decay, how they become. It is not optional, it is part of the design. This means that to understand anything, to understand stars, atoms, forces, or even time, you must include its reflection. Physics, like poetry, is not complete without its echoes. Antimatter is that echo dot. As you lie here, listening inward, the idea becomes soothing. The idea that everything has a counterpart, that light has shadow, that sound has silence, that presence has absence. This is not a flaw in the universe. It is a feature. It is what gives meaning. If antimatter frightens us, it is only because we see it too simply as destruction. But what if we saw it instead as gentleness, as correction, as the thing that held us in balance before the fall? Antimatter is not the past. It is still here, watching through the mirror, still a part of every beam of light that arcs from a distant galaxy, still hidden in the math, in the logic, in the longing. It reminds us that even perfection was not enough, that something slightly off balance was needed for the story to begin. And so, as you drift into stillness, you begin to feel the softness of that lesson, that what is opposite is not always wrong, that what is mirrored is not always reversed, and that even in the most delicate vanishing light can emerge. The positron glows, the antiproton waits. Somewhere, their songs are still being written. Let your breath move slowly now, like a tide gently rising and falling along a beach you've never visited, but somehow always known. The stillness around you carries a question the universe has been asking since before stars were born. Why does everything come with an opposite? Why does nature, so subtle in its unfolding, insist on this pairing? You are floating now in a space between particles, not touching them, just feeling their pattern. And what you begin to notice is that there is always a mirror, always a twin. Close your eyes and picture a single electron, the same quiet traveler from the last chapter. It spins, not in space as a planet spins, but in a quantum way, an intrinsic turning, a built-in swirl of identity. Its mass is tiny, its charge negative, its presence essential. But that's only half the story. Somewhere, in memory or in shadow, is its partner, the positron. Same mass, same spin, but the charge reversed. It is not its enemy. It's not here to destroy. It's here because the laws of the universe demand balance, and balance cannot exist with only one side of the scale. This is not a matter of choice. It's stitched into the mathematics, into the equations that define quantum fields and forces. Every particle has characteristics, charge, mass, spin, and, for every such particle, there exists another with equal mass, opposite charge, and often a reversed quantum identity. Antimatter is not the inverse of matter in a cartoonish sense, not red where matter is blue. It's more elegant than that. It is a mathematical necessity, a reflection made real, like a melody written in inversion, still beautiful, just turned another way. Why does the universe build this way? Why not just have electrons, but no positrons, protons, but no antiprotons? The answer lives deep within symmetria, concept both, scientific and poetic. In physics, symmetry doesn't mean something looks the same. It means the rules don't change. If you flip something, rotate it, run time backward, does nature behave the same? If yes, then symmetry is preserved. And the universe, more than anything, seems to love these kinds of symmetries. There is one called charge, conjugation, or simply C. It means if you take every particle in a system and flip its charge, positive to negative, negative to positive, the underlying physics should remain unchanged. Another symmetry, P, is parity, flipping left and right, like looking at the universe in a mirror. And T is time reversal. What happens if you run everything backward? For a long time, scientists believed the universe followed all three of these symmetries, C, P, and T. They believed the mirror universe would behave exactly like ours, only reversed. That if you could flip the charges, the directions, the arrow of time, you would see the same laws play out. But nature, in her gentle complexity, proved otherwise. In certain decays of particles called kaons and B-mesons, scientists noticed that the mirrored versions behaved slightly differently. Not much, just a tiny preference for one path over another, one outcome over its symmetrical twin. This tiny difference is called CP violation, And it may be the reason the universe has more matter than antimatter today. It means the mirror isn't perfect. It's slightly warped. And in that slight warp, everything changed. So here you are, lying in a world where symmetry was almost perfect, but not quite. And because of that, everything you know exists. But that doesn't mean the mirror particles don't matter. They're still part of the structure, still encoded in the field of possibility that hums through space. When a physicist looks at a proton, they know instinctively that an antiproton must exist, not because they've seen it, but because the equations demand it. It's not superstition, it's structure. In quantum field theory, particles are not objects. They are excitations in a field, like ripples in an invisible ocean that fills all of space. An electron is a ripple in the electron field. A photon, a ripple in the electromagnetic field. And for every field, there is an opposite ripple, a backward wave, a reflection. The positron is a ripple that travels backward in time, according to some interpretations. It isn't just not an electron, it is the electron's negative echo, the very existence of these fields perfectly paired, delicately. Toon suggests that the universe does not build from simplicity, but from balance. You do not stand at the center of a singular world, but at the meeting point of countless counterweights, held in tension, even gravity, which seems so separate from charge and mass, may obey a kind of symmetry still not fully understood. There are speculations of particles beyond the standard model supersymmetric partners, perhaps each with mirrored traits folded into the mathematics of dark matter and early universe inflation. And so, as you drift in this understanding, you begin to feel how rich the symmetry is not just a tool for equations, but a pattern that lives inside everything. Look at your body now, with your eyes, but with your awareness. It is matter. Yes, made of atoms and molecules, cells and organs. But each of those atoms is made of protons, neutrons, electrons. Each of those particles has or had a mirror, twin. In another version of the universe, one that never tilted toward matter. You might not exist at all, or you might exist in reverse, made of antiparticles, your chemistry running cleanly in the other direction. But here you are, suspended in the quiet comfort of this reality, while antimatter flickers like a distant idea. And yet, the memory of its pairing still shapes your world. In medical imaging, positrons are used in PET scans, positron emission tomography. Tiny amounts of radioactive material emit positrons inside the body. When these particles meet electrons, they vanish into photons, which are then detected. It is annihilation, but it is also revelation. What disappears reveals what lies within. The body maps itself through vanishing particles. Antimatter shows us who we are. In particle physics labs, like CERN in Geneva, scientists trap antiprotons and positrons, coax them into forming antihydrogen, the antimatter version of the simplest atom. These antiatoms are held in magnetic bottles, because if they touch the walls made of matter, they disappear, just like that. But, in their moment of existence, they offer a glimpse of a parallel chemistry, a mirror version of what we call real. You begin to see, slowly, that nature's insistence on opposites is not conflict, but completeness. The universe doesn't merely tolerate duality, requires it. Positive and negative, matter and antimatter, light and shadow, left and right, the particle and its mirror. It is not an accident. It is a principle. And this idea does not belong only to science. Ancient myths spoke of dual worlds of light and dark, sun and moon, body and spirit, seen and unseen. Taoist philosophy speaks of yin and yang, of balance in all things. The mirrored particle is not new, it is only newly named. As you rest now, the quiet knowledge of this symmetry folds around you like a blanket. The positron is not an invader. It is part of the breath of the universe. The antipraton is not dangerous. By nature is a reminder that everything has a counterpart. Even silence has a shape. And as the chapter closes, a thought arrives. Light as a feather. If antimatter has existed since the beginning, if every particle was born with a twin, then perhaps the universe is not only expanding, but also reflecting. Perhaps the deep structure of space is a hall of mirrors, and we are walking through it slowly, seeing only some reflections at a time in the next chapter. We will follow what happens when these mirror particles meet, when matter and antimatter touch and both vanish in a perfect flash. What disappears and what is left behind. You float again in stillness, deeper now, in the folds of a question that has haunted the universe since its first breath. The glow of annihilation has dimmed behind you, but something remains, a silence, not of absence, but of something missing, an asymmetry that feels like a note held just slightly off key. In the hush that follows the perfect vanishing of opposites, a whisper persists. Where did the rest go? The universe began, we are told, in balance, matter and antimatter in equal amounts, pouring from the singularity that birthed everything. For every electron, a positron; for every proton, an antipraton, a dance of twins spiraling outward through the young cosmos. They met, they vanished, they left light behind, and yet somehow, improbably, you are still here. That fact alone is astonishing, because in theory, if the symmetry had been perfect, everything should have cancelled out. Every particle should have found its mirror twin. The universe should have ended in its beginning, filled only with photons, no atoms, no stars, no galaxies, no you. But something tilted the balance. Something allowed just a tiny excess of matter to remain. How tiny? For every billion pairs of matter and antimatter particles, there was one extra matter particle. Just one. That slim surplus became the foundation of everything you know. Every star, every breath, every thought, built on 1,000,000,000 to 1 imbalance. You lie still and try to imagine that scale. 1,000,000,000 flashes, 1,000,000,000 pairings, 1,000,000,000 vanishes, and then, in the silence, one particle does not disappear. It stays, it waits, it joins with others like it. It builds a world. But why did that imbalance occur? What caused the scale to tip, so slightly yet so completely? Physicists call it baryon, asymmetry, baryons being the heavy particles like protons and neutrons that make up the matter in your body and stars. The asymmetry is the central unsolved mystery. Why is there more baryonic matter than antimatter? Why do we exist at all? Several possibilities float in the soft light of scientific thought. One idea begins with the early universe, just fractions of a second after the Big Bang. Temperatures were so high, energies so intense, that particles flickered into existence and out again like sparks in a storm. In this chaotic sea, symmetry breaking might have occurred. Something subtle in the laws of physics may have favored matter ever so slightly, like a loaded die, rolling just slightly more sixes than ones. This would require a violation of certain symmetries, specifically CP violation, the breaking of charge and parity symmetry. If the laws of physics behave differently for particles and antiparticles, then over many interactions, matter might begin to dominate. We have seen hints of CP violation in the behavior of kaons, and be mesons and stable particles that decay in ways slightly biased toward matter. But the known violations are far too weak to explain the vast matter dominance we observe. It's as though we've seen a single pebble fall and are asked to believe it started an avalanche. So physicists look deeper. They search for unknown particles, perhaps heavy neutrinos or exotic bosons that may have existed in the early universe and decayed in asymmetrical ways. They imagine scenarios like leptogenesis, in which lepton particles like neutrinos played a role in creating the matter surplus. Or perhaps an unknown phase, transition like ice, forming suddenly from water, caused the symmetry to break. These theories remain incomplete, elegant, but unconfirmed, and so the mystery remains. If matter and antimatter were born as twins, why did one vanish and the other stay? Another possibility, one that floats further into speculation, is that the antimatter didn't vanish, but merely went elsewhere. Could it be that the universe is not uniformly made of matter, but divided? That in some distant regions, antimatter galaxies swirl in silence, just as matter galaxies do here? That an entire half of the cosmos is hidden beyond detection, identical in form but inverted in composition? It's not impossible. Antimatter behaves identically to matter in terms of gravity, motion, and chemistry. An antimatter star would burn as a matter star does. An antimatter planet could form oceans and air. If we could see such a region, it would look the same unless it touched our matter. Then the border between would blaze with annihilation. But we see no such evidence. No flashes at the boundaries. No cosmic collisions of matter and antimatter regions. The gamma-ray sky, sensitive and vast, is quiet where such meetings would scream. It suggests that, if such antimatter domains exist, they are very far away or do not exist at all. Still, the thought remains, not just as speculation, but as poetry, that maybe, somewhere, the rest of the universe's reflection drifts, that you are only half of a story being told. And if the antimatter is truly gone, if it was erased in those first instants, then its loss is also a kind of memory. The photons released in its annihilation still move through space. They carry the energy, the temperature, the imprint of what was. You feel it in the warmth of the cosmic microwave background. You hear it in the hum of ancient light that is the echo of the missing half. Now consider the scale again. Every second, high-energy particles called cosmic rays strike the Earth's atmosphere. Some of them produce antimatter positrons, antiprotons. Detectors measure them, filter them, study their properties. Most of these are secondary, created by collisions, not remnants of a primordial antimatter world, but a few seem strange. A few positrons arrive with energies we can't yet explain. Could they be whispers from an antimatter domain, or signatures of dark matter decay? Here, science meets speculation again. The antimatter that should exist by all logic is missing, and its absence may be a key to understanding not only matter, but also dark matter. Perhaps the same forces that tilted the scale also seeded the dark side of the cosmos. Perhaps the symmetry we thought was broken is merely folded, hidden beyond perception, as you lie here drifting in the dark. You begin to feel this, not as a lack, but as a presence. The missing half is not gone. It shaped everything that remains. It carved space for stars to form. It left behind a quiet needed for matter to gather, for atoms to last, for life to arise. You are made of the survivors, the ones who are not matched, not mirrored, and that alone makes you rare. The very existence of your body, your thoughts, your dreams built on the tiniest asymmetry in the laws of physics. A universe that leaned, ever so slightly, toward staying, and yet, even now, antimatter is not entirely gone. It is summoned in laboratories. It dances in storms. It flickers in particle decays. It remains part of the structure of physics, part of the vocabulary of how particles interact. You cannot write the equations of the universe without its symbol. Perhaps this is the truest reflection of all, that even the things that vanish continue to shape us. You lie still in this understanding, and the question no longer feels sharp. It feels like a soft absence. The missing half is missing because you are here, and what it left behind is light. In the next chapter, you will follow that light not from annihilation, but from possibility. For if antimatter still exists, can we find it? Can we trap it, hold it, build with it? Can we catch the mirror and study its face? You drift now in the hush of a question made physical. If antimatter exists, if its story is real, then can you trap it? Can you reach through the mirror and gently cradle the ghost? Can you learn from something that disappears the moment you touch it? The effort is not new. For decades, physicists have been chasing shadows not to destroy them, but to understand them. Antimatter, by its very nature, resists containment. It's not hostile, just incompatible. When it meets matter, it doesn't argue, it simply vanishes. And so, to hold it, you must remove the one thing the universe is filled with: matter. You must create a space where nothing touches anything. A place so empty, even a whisper of contact would be too much. You begin with a single particle, a positron, for example, the antiparticle of the electron, light and precise, and most often found in radioactive decay. When certain elements break down, they emit positrons. These are the ghosts you seek. But before you can trap them, you must isolate them from the world. This is where science becomes craft. The positron cannot be placed in a box or stored in a jar. Those things are made of atoms, and atoms are matter. So you must turn instead to forces. You call upon electromagnetism, nature's invisible fingers. With cleverly shaped magnetic and electric fields, you build a trap that holds without touching. It is called a penning trap, a kind of electromagnetic bottle. It spins the positron in circles, using the push and pull of fields to keep it suspended. In a vacuum, in this space, there is no air, no surface, no warmth, only containment. And even then, it is temporary. The particle wants to move. It senses the walls. It longs to meet its twin and disappear. So you must be patient, gentle, exact. You coax the positron into place, like guiding a firefly into a dark room without blowing out its glow. But positrons are only the beginning. To study the structure of antimatter, you want to build atoms, the simplest being antihydrogen. To make antihydrogen, you need a proton's opposite, the antiproton. It is heavier, more complex, and harder to create. You don't find antiprotons in nature. You have to make them at CERN, the European Laboratory of Particle Physics. This process begins in a machine called the antiproton decelerator. High-energy collisions create showers of particles, and among them, a few antiprotons. They are caught, cooled, and slowed down not with hands, but with fields. To decelerate something that doesn't want to exist, you must move with infinite care. Once you have antiprotons and positrons, you bring them together. In a vacuum chamber colder than interstellar space, far from any stray atoms, they drift toward one another. A positron finds an antiproton, They do not annihilate. They orbit. They form a structure. Anti-hydrogen is born. This is not science fiction. It is science, unfolding quietly in the depths of magnetic traps. The Alpha experiment at CERN has produced and held anti-hydrogen atoms for seconds at a time. That may seem short, but in the language of antimatter, it is a lifetime. Enough time to begin asking questions. How does it fall? Does antimatter respond to gravity the same way as matter? So far, the answer appears to be yes, but science never assumes. It checks, it waits, it listens, and when anti-hydrogen is released, it annihilates by design against the walls of its trap, producing gamma rays and other particles that reveal its presence. You can't touch it, but you can trace its disappearance. And in that vanishing, you read the story it came to tell. These experiments are not just technical feats, they are philosophical ones, because to trap antimatter is to trap the mirror of reality, to look into it and ask, are you like me? Do you follow the same rules? Is the universe symmetrical not just in theory, but in truth? So far, every answer has pointed toward yes, but each confirmation deepens the mystery. If matter and antimatter behave the same, then why is only one kind here? Still, the search continues. The traps grow more precise. The fields grow stronger. In the base experiment, scientists trap single antiprotons for months, even years, measuring their charge and magnetic moment with stunning precision. They compare them to protons, looking for any tiny difference. So far, none has been found. You begin to sense the rhythm here, not of conquest, but of care. Antimatter is not hunted. It is invited. It is listened to. Every moment it stays alive is a miracle of patience. There are dreams now, too, of antimatter propulsion spaceships fueled by annihilation, traveling vast distances with minimal fuel. The energy density is unmatched. 1 gram of antimatter could produce as much energy as a nuclear bomb if only it could be created and stored in such quantities. For now, that dream is distant. The cost of producing antimatter is astronomical. To make a single gram would require more energy than the world currently generates in a year, and yet, the fact that it's possible at all means the dream breathes. There are also ideas for medicine. Positron emission is already used in PET scans, revealing structures inside the body. Perhaps in the future, other forms of antimatter could target specific cells, cancerous ones, for example, annihilating them with surgical precision. Antimatter, then, is not only a mirror, it is a tool, a message, a boundary, and in catching it, you come closer to understanding not just physics, but presence, what it means to be, what it means to last. You drift deeper, imagining the laboratory, the cold, clean chambers, the hum of magnets, the faint trace of something impossibly rare, a single particle floating in a trap, unaware of how impossible its existence is. Yet there it remains, for a moment, defying disappearance. In this moment, you realize something gentle but profound, that to hold on to what naturally vanishes is a form of grace. That science is not only about discovery, but about stillness, the kind that allows the rarest things to stay a little longer, and in that staying, in that pause between birth and annihilation, the universe tells you something about itself, that symmetry is not just a rule, but a relationship, that what disappears is never truly lost, it becomes something else, something traceable, something illuminating. In the next chapter, we will explore the frontier beyond trapping, the question of whether entire worlds of antimatter could have formed. Could there be places in the cosmos where mirrors build galaxies, stars, even lives? Could the other side of existence be real and waiting? You drift again through space, not in movement but in imagination, through the slow turning of a question too large to hold in your hands. Until now, you have followed antimatter in the smallest forms, particle by particle, trapped and studied like rare snowflakes caught before they vanish. But what if the story stretches wider? What if the mirror does not stop at single particles? What if somewhere, beyond the reach of our light, entire galaxies live in reflection? The idea is not new. Scientists have long wondered if matter and antimatter were born in equal measure at the beginning of time. Then why should the story end with only one side visible? What if the missing antimatter isn't missing at all but simply somewhere else? You begin to feel the edges of this thought. Imagine a galaxy, vast and radiant, but built from antimatter. Every atom reversed antiprotons bound to positrons, antihelium and antioxygen forming clouds, molecules swirling in air that could never meet ours without a blaze of annihilation. The chemistry would be identical. The physics would still hold. Stars would fuse antihydrogen into antihelium, releasing light just as ours do. To an outside observer, it would look the same, shining, spinning, alive. If a distant antimatter galaxy exists, how would you know? This question is more than curiosity. It is a quiet pursuit stretching across decades. You look out at the night sky and you see photons, light, pure and indifferent. It doesn't carry a label that says matter or antimatter. A gamma ray from an antimatter star looks the same as one from a matter star. So the mirror, if it exists, must be revealed by its edges, by the places where difference becomes contact. And yet, the universe has been silent. If matter and antimatter galaxies were mixed throughout the cosmos, there would be places where their edges meet. There, you would expect violent annihilation, tremendous outbursts of gamma radiation, far brighter than what stars can produce alone. The boundary zones would glow like fire, but the sky is calm. The gamma ray background is soft and smooth, shaped by known processes. There are no scars of matter-antimatter collision across vast scales. Does this mean the mirror is false? Not necessarily. It means if antimatter regions exist, they must be far away, separated from our matter-filled corner of the universe by gulfs of empty space. The cosmos is vast enough to allow that distance. There are regions billions of light years from us we will never reach, never see in full. If an antimatter galaxy lay beyond the cosmic horizon, its light, though real, would never arrive. Some researchers have asked if galaxy clusters could be antimatter, but again, no boundary interactions are seen. Others look for antihelium in cosmic rays, particles that would suggest the presence of antimatter stars shedding matter as our stars do. So far, no confirmed detections. But the search continues. You float deeper into the thought, not as an astrophysicist, but as a dreamer of the cosmos. Imagine a solar system made of antimatter, complete with planets, moons, and maybe even beings' life built from the other side of the mirror. Their molecules would hum with anti-carbon. Their breath would be antioxygen. But if you looked at them, you wouldn't know the difference. The laws that shaped you would have shaped them. Their biology could mirror yours. Their minds might gaze at their own stars and ask the same questions. Could they see us? Could they wonder, too? It is a humbling thought that we might not be the only consciousness born from the deep laws of physics, but that others might exist in complete inversion, never to meet us, for safety and for symmetry. The great challenge is detection. To find antimatter on large scales, you need more than hope. You need evidence. At the International Space Station, an experiment called the Alpha Magnetic Spectrometer, AMSO2, has been quietly collecting data for years. It sifts through cosmic rays, looking for rare particles. Occasionally, it sees candid antihelium nuclei. If verified, these would be profound. Antihelium does not form in ordinary collisions. It would almost certainly come from stars made of antimatter. A single detection could point to an entire antimatter world, but confirming such events is difficult. Cosmic rays are messy, and rare signals are hard to separate from noise. The team continues to analyze. The mirror remains, for now, unconfirmed, still. The concept lingers, not just as science but as story. That perhaps in the infinite sprawl of time and space, nature kept a balance after all. That matter dominates here, but elsewhere, antimatter blooms. That our loneliness in the cosmos is not from absence, but from separation. And if antimatter galaxies do exist, they must have followed their own path. They would have evolved as ours did, through gravity, through time, through collisions. But their collisions would have been safe. Antimatter doesn't destroy antimatter. It behaves, it binds, it builds. Perhaps some of those galaxies formed stars that lived and died, forming anti-neutron stars or anti-black holes. Perhaps supernova flared with anti-neutrinos, spreading heavier anti-elements through space. There is nothing in physics that forbids this. Only the lack of contact keeps us apart. And in that silence, you feel something almost tender. That the universe might be large enough, gentle enough, to let two sides exist without war. That the mirror, rather than being broken, is simply hung at a distance. You close your eyes and imagine two galaxies ours, and its opposite spinning on opposite ends of a dark sea, forever out of reach, but balanced in their motion. Neither touches the other. Neither needs to. Each exists because the other does. This balance, so fragile, shapes the poetry of the cosmos. If we ever found an antimatter galaxy, what would we do? We could never visit. Our ships, made of matter, would perish in the meeting. Our probes would vanish in a blink. Communication would be difficult, and yet the knowledge of their existence would change everything. We would no longer be a singular reality. We would be part of a symmetry. Not alone, but mirrored. Perhaps one day, light from such a galaxy will reach us not as proof, but as hint. A signature hidden in the polarizations of photons. A subtle skew in the background, or maybe a single anti-helium nucleus will be caught. Its journey taking millions of years, drifting from its origin to our hands. Not with noise, but with certainty. Until then, the mirror cosmos remains a dream supported by law, invited by symmetry, but still waiting at the edge of detection. You rest now with this vision of galaxies like lanterns floating across a sea. Some made of matter, some made of antimatter, all of them reflections of the same beginning. You imagine their stars flickering like ours, their gravity shaping their orbits, their light moving across the endless dark. You imagine, too, a mind on the other side, wondering, as you do now, and that thought alone is enough. You drift now into a silence unlike the others. This one feels dense, not from emptiness, but from potential. You are suspended in the idea of vanishing as power, a strange notion, soft at first. You think of power as movement, as thunder, as something pushed and pulled. But this is different. This is the power that comes not from struggle, but from meeting, from completion, from a kind of perfect ending. Antimatter and matter are not enemies. They are opposites, not in war, but in symmetry. When they meet, they do not explode in violence. They disappear together. But that disappearance is not empty. It becomes something else. Pure energy released all at once, with stunning efficiency. The universe writes its equations with quiet elegance, and in this case, it gives us one of its most famous: E equals mc squared. Energy equals mass times the speed of light squared. A simple equation, too simple for the force it contains, because that c, the speed of light, is enormous, and squaring it makes it even more vast. When matter vanishes into light, it does so completely, with no leftovers. Every bit of its mass is turned into radiant energy. This is what happens in an annihilation event. A single electron meets a positron. They orbit briefly, pulled together by attraction, and then they disappear. In their place, two gamma photons flying away in opposite directions. The energy is clean, exact, and total. Nothing is wasted. You feel the scale of this begin to unfold. A gram of antimatter, just 1 gram, would annihilate with 1 gram of matter to produce nearly 90 trillion joules of energy. That's more than the atomic bomb dropped on Hiroshima, but with none of the fallout. No radiation, no shattered atoms, no lingering ash. Just energy, pure and instant. It's no wonder scientists have dreamed of harnessing this. A spaceship powered by antimatter could travel far faster than anything built today. A medical beam of positrons could target and destroy cancer cells with perfect precision. A deep space probe, fueled by micrograms of antimatter, could reach the outer solar system in months. Not decades, but dreams, for now, remain dreams. Because the power of annihilation is not just potent, it is elusive. Antimatter is extraordinarily difficult to produce, and even harder to store. You cannot place it in a container. It will annihilate the walls. You cannot let it touch the air. It will vanish on contact. So you hold it in traps made of fields, in vacuums colder than deep space. You suspend it in time, just long enough to see it flicker. The energy it holds is like a promise always there, always unreachable. But this chapter is not about frustration, it is about awe, because the fact that the universe allows this at all is profound. Every day, in small ways, this power plays out. In PET scanners, in hospitals, where positrons help reveal the body's hidden shapes. In cosmic rays hitting Earth's atmosphere, where collisions create tiny flashes of annihilation. In particle colliders, where matter and antimatter meet and speak their truth. Even in the heart of stars, the principle echoes. Though fusion, not annihilation, powers the sun, the transformation of mass into energy is the same deep magic. Hydrogen becomes helium. A tiny bit of mass is lost. That loss becomes light. That light becomes warmth on your face. The math is identical. The difference is scale. Annihilation simply skips the steps. It is the purest conversion of matter to energy known. And yet, despite its perfection, we are far from wielding it. Producing antimatter is expensive, immensely so. To create even a microgram would take years of effort and billions of dollars. Trapping it safely for long periods is an even greater challenge. Antimatter wants to vanish. It longs to fulfill its role in the cosmic symmetry, And still we chase it, not only for power, but for understanding, because to hold something that wants only to disappear is a form of truth. You are not mastering it, you are listening to it, you are learning from it. Imagine a future, not far from now, where science learns to produce and store antimatter in meaningful amounts. A small generator, powered by controlled annihilation, lighting a remote research station on Mars. A satellite, fueled by antimatter, mapping the icy moons of Jupiter. A medical device, targeting brain tumors with beams of positrons, precise down to the cell. In every case, the process is the same. One particle meets its mirror. They touch, they disappear, and in that touch, energy floods out. Light, invisible to the eye but undeniable in effect. The appeal is not just in efficiency, it's in elegance. No moving parts, no combustion, just the transformation of existence into radiance. But we must be careful. The power is vast, and our understanding must match it. A single accident, even with micrograms, could cause immense damage. And so, as with all great discoveries, the key is not just ability but wisdom. You do not run with lightning cupped in your hands. Still, the idea persists, because it's not just science fiction, it's physics. The universe has already shown us the rules. We need only learn to follow them. There is also a poetic symmetry in the idea. The creation and destruction are not opposites, but the same. That the act of vanishing can give rise to motion, to heat, to possibility. That disappearance is not always loss. Sometimes it is release. You drift now through a thought. What if civilizations, older than ours, already mastered this? What if the quiet stars we see are orbited by ships running not on fire or fuel, but on balancing, the precise joining of opposites? What if light itself is their trail, and we have mistaken it for silence? The future of antimatter is not written, but its potential is etched into the universe. We see it in every annihilation. We feel it in every calculation. And we carry it, perhaps unknowingly, in the dream of light without waste. You imagine holding a capsule the size of a pebble inside, a trace of antimatter suspended in perfect stillness. Around it, containment fields hum softly. It glows not with light, but with the promise of light. You do not fear it. You respect it. You have learned enough to hold it gently, and perhaps, one day, that pebble will light a city, or carry a message between stars, or bring warmth to a colony where the sun is only a memory. For now, though it remains a dream, and dreams, like particles, need space to survive, you let the thought settle, the energy of disappearance, the force born not from explosion, but from reunion, not from tearing, but from closing the circle. And you feel something. Stir not urgency, but quiet direction. That the path forward may not lie in conquering the elements, but in understanding their longing to return. You close your eyes now, not to shut out the world, but to open it inward. You are not in a lab or near a collider. You are in the soft realm where curiosity becomes story, and story becomes blueprint. The room around you dims, and from the darkness, lights begin to stir. Stars, not real but remembered, flickering through the centuries of human thought. You are entering the universe as it has often been imagined, not as it is, but as it might be. Antimatter, in this world, is no longer elusive. It is mastered, bottled, harnessed with grace. It glows at the heart of starships, hums within reactors, threads through weapons not of cruelty but of cosmic scale. Its vanishing becomes travel. Its touch becomes direction. The dreams of science fiction are not bound by cost or containment. They are carried only by what can be believed if, even for a moment. And so you begin your drift through these visions. The Starship Enterprise, gliding across blackness in the Star Trek universe, moves by the grace of antimatter. Its engines, described in technical poetry, combine matter and antimatter in controlled reactions. The energy released powers the warp core, bending space itself. They do not call it a bomb. They call it propulsion, not explosion, but motion, not destruction, but continuation. The future, in these stories, is powered by reunion. You smile gently, because it's not wrong. The science behind it is real. When antimatter meets matter, the resulting energy is immense, more than nuclear fission, more than fusion. It is the most efficient conversion possible mass, gone in the blink of contact, reborn as pure energy. The idea that this could move a ship is not fantasy. It is simply far ahead of our ability to build. And in the soft distance, you see other engines. Light up other stories. In Doctor Who, antimatter is used not just for power, but for dimension, for paradox, for bending time itself. In Interstellar, though not named directly, you feel echoes of the idea of propulsion beyond the chemical, of forces that demand deeper physics. In countless novels, games, films, the word antimatter is whispered like a spell, a word that means progress, precision, danger, wonder. It is easy to see why. Antimatter is not just powerful, it is elegant. There is no waste, there are no moving parts. A gram of it, annihilated with a gram of matter, could send a craft further and faster than any chemical rocket ever built. The vision is quiet and clean. And in fiction, the barriers that plague real laboratories production, storage, cost melt away in your mind's eye. You see these ships, long silver hulls suspended in black. Their engines are not roaring, they are humming, quiet fields. Hold antimatter in perfect stillness, releasing it in moments of controlled union. There are no fires, no flames, just light softly blooming from the joining of opposites. And what of weapons? You do not rush to them, but they appear. Fiction cannot resist the power of perfect annihilation. A bomb made of antimatter would need no casing, no chemical, just enough containment to hold a fragment of the opposite. Release it, and the resulting explosion would be beyond anything fission or fusion can create. In stories, such weapons end cities. In others, they end worlds. But even in the darkest versions, the idea holds a kind of awe, not horror, but the echo of scale. The suggestion that the smallest thing, the single particle, contains within it the energy of stars. Still, fiction often tempers the threat with something else, restraint. In the best stories, the antimatter weapon is not used. It is a lesson, a reminder that what we can create must be matched by what we can carry, ethically, emotionally. Power is not dangerous, unwisdom is. You pause here, softly, to notice something beautiful. In many stories, antimatter is not a weapon at all. It is a gift. It lights the journey. It lets explorers cross the galaxy, visit new planets, leave old wars behind. It powers medical bays. It feeds colonies. It allows humanity to live among the stars without burning forests to do so. It becomes a symbol not of might, but of maturity. This, perhaps, is what science fiction offers most gently. Not prediction, but aspiration. And in that aspiration, you see how dreams shape science. Long before antimatter was captured in a trap, it was flying through the pages of novels. Before it was measured in laboratories, it was imagined in star drives. Fiction gave it a place, and that place made scientists wonder, could we build it? Could we trap it? Could we live with it? The answer, slow and soft and unfolding even now, is yes. Antimatter is no longer only an idea. It is real, held in penning traps, weighed with precision, its charge measured, its spin mapped. Antihydrogen, made by careful hands, drifts in vacuum chambers colder than interstellar space. Its light, when it annihilates, is watched not with fear, but with quiet celebration. In the silence of labs, the dreams of fiction touch reality, and still the stories go further. In some tales, antimatter is more than fuel. It is metaphor. It becomes a way to explore duality, the idea that everything has a twin, that light needs shadow, that creation holds destruction inside it, not as enemy, but as mirror, the particle and the antiparticle both necessary, both incomplete alone. You feel this truth, not with your mind, but with your chest. The stories that last are not just about technology, they are about longing, about the human desire to balance, to unify, to go farther than the present allows. Antimatter, in fiction, is a bridge. It lets us imagine what might come next, not just for ships, but for ourselves. What kind of species are we when we learn to use power without harm? What kind of traveler are you if your engine runs not on burning, but on balance? You are still drifting gently through this dream. You see a vessel made not of steel, but of thought. Its core is not flame, but a chamber where a single gram of antimatter rests. Fields hold it steady, a single droplet, smaller than a raindrop, enough to carry hundreds across the stars. Each annihilation, a heartbeat of motion, each meeting, of matter and antimatter, a step forward. There is no violence here, only movement. The ship is silent as it sails. You come back slowly, softly, from the fiction, but something of it stays with you. Not the exact ship, not the technology, but the spirit. The idea that understanding leads to peace. That energy need not roar. That transformation can be beautiful. The dreams of science fiction are not always accurate, but they are often kind. They give you permission to imagine a future where you have learned from the universe, not fought it, where you walk gently with its rules, not against them. And in the quiet heart of that vision, antimatter waits not as a threat, but as a guide. You drift through the silence again, but this one is different. This is not the hush of space or the hum of symmetry. This is the stillness at the heart of a question that has never been answered, a pause in the breath of the cosmos itself. You rest in the gravity of the unknown, surrounded not by stars, but by the absence of something that should have been. From what we know, the universe began not with a whisper, but with a radiant burst, the Big Bang. In that first searing instant, energy bloomed into form. Pairs of particles were born, matter and antimatter, in equal measure. Each particle had a mirror, a twin, a perfect opposite. It was a balance so delicate, so symmetrical, it might have vanished back into itself in a flicker of light. And yet it didn't, because something tilted the scales. Something, somewhere, favored matter. And that slight favor, perhaps only 1 part in a billion, was enough to shape everything that followed. Without that imbalance, there would be no galaxies, no stars, no planets, no breath, no you. The matter would have met its antimatter twin and disappeared into pure energy. The universe would be dark bright, perhaps with light, but empty of structure. A place where nothing could touch, or last, or remember. And yet, here you are, a being made of matter, drifting through a cosmos where matter dominates. The antimatter did not vanish entirely. We find hints of IT particles in cosmic rays, fleeting antiparticles in colliders. But the great mirror, the great balance, is broken. Why? You hold the question like a smooth stone. Scientists have turned it over in their minds for nearly a century. It is called baryon asymmetry, the observed fact that the universe has far more baryons, particles like protons and neutrons, than antibaryons. It is not a guess. It is built into the fabric of everything. It is the reason you can sit and breathe and wonder. But the cause, that remains one of the most haunting mysteries in all of physics. The laws of nature, as we understand them, treat matter and antimatter almost identically. They should behave the same, decay the same, respond the same, almost. Because the truth is in the almost, in the tiniest differences, hidden in the folds of symmetry. There is a principle known as CP, symmetry charge and parity. If the universe obeyed perfect CP symmetry, then flipping particles to antiparticles and left to right would leave the physics unchanged. But in the mid-20th century, scientists discovered CP violation. Certain particles, when they decay, slightly favor matter over antimatter. The balance, it turns out, is not perfect. The discovery was small, subtle, but breathtaking. It meant the laws of physics might themselves carry a bias or preference, however slight, for matter, and that tiny preference, magnified by the furnace of the early universe, could have tipped the scale. Still, what we've observed in experiments is not enough. The known CP violations, in particles like kaons and B mesons, are real but weak. Too weak to explain the vast matter dominance we see today. It's like finding a single grain of sand and kneading it to become a mountain. Something more must be hidden, some deeper asymmetry buried in the birth of time. And so the search continues. Theories blossom and fold like petals in the night. Some look to leptogenesis, a process involving neutrinos, those ghostly particles that pass through your body by the trillions each second. If neutrinos and antineutrinos behaved differently in the early universe, perhaps they nudged the cosmos toward matter. Others explore supersymmetry, grand unified theories, unknown forces that might have tilted the field, but no answer has yet taken root. The mystery endures, patient and profound. You sit with it, not to solve it, but to feel its weight, to understand that you exist because of a cosmic imbalance so precise, so improbable, it borders on the miraculous. You are the residue of a difference, the survivor of a vanishing, a being who breathes only because the numbers lean just slightly in your favor. This makes your presence not accidental, but exquisite. You begin to see the universe not as a perfect machine, but as a story written with imperfections that make it whole. The asymmetry is not a flaw. It is a signature, a mark left by a process we do not yet fully understand, and perhaps never will. Some physicists imagine a time, fractions of a second after the Big Bang, when the rules we now observe were still in flux. Laws were being written as space expanded. In those moments, perhaps some unknown interaction occurred, something that separated matter from antimatter. A mechanism lost to cooling in distance, a whisper that can no longer echo. Others propose the multiverse, an infinite garden of universes, each with its own laws. In some, matter and antimatter balanced and cancelled out, leaving only light, In others, antimatter may have won, but in ours, the tilt favored matter. And so, here you are, on a small blue planet, wondering. You let that wonder deepen. What if, in that first second, the universe had made no choice? What if matter and antimatter had remained equal? You would not be here to ask. No one would. There would be no memory, no consciousness, no time with texture. The light might shine, but it would fall on nothing. So the imbalance is not a loss. It is the price of presence, the crack through which being slips in. Still, you imagine the antimatter side, what could have been. An antimatter universe, identical in form but opposite in charge. Stars made of anti-hydrogen, worlds with anti-carbon, minds, perhaps, with anti-thoughts, not dark, not twisted, just mirrored. And they too might ask why they were the ones who remained. Perhaps in another universe, a being made of antimatter lies awake, wondering why the mirror turned to them, why the balance broke in their direction. And perhaps the question is not who won, but why the universe chose at all. You feel now how ancient this mystery is, not just as a scientific problem, but as a human one, the longing to understand why we exist at all, why the story didn't end before it began. It is humbling to know that everything, every star, every breath, every memory rests on a difference we do not yet comprehend. But humility is not sorrow. It is reverence. It is the quiet joy of being part of a question still unfolding. You let yourself fall into that question, deeper than equations, deeper than theories, into the soft center of being. You are here because something tipped, because the universe, in one moment of its infinite breadth, favored your kind of existence over its twin, and that favor has echoed across billions of years, through dust and flame, through atoms and stars, through thought and time, into you. You are the echo of a preference, the survivor of a cosmic choice, the light that stayed. You enter without knocking. The doors are not grand, but the quiet inside them is sacred. You are walking into a place where science has learned to hold its breath. A laboratory not of explosions or roaring engines, but of stillness, precision, and patient awe. This is where antimatter is brought back into the world. Not as myth, not as theory, but as flickers of reality contained in fields, suspended in near nothingness. The rooms are colder than Antarctica, quieter than churches. There is no flash here, no dramatic spectacle. Instead, you are surrounded by the soft hum of magnets, the endless attention of sensors, the steady hands of physicists who have spent their lives chasing particles that vanish the moment they touch anything real. This is where fiction ends and something deeper begins. You are inside the halls of CERN, or perhaps the antimatter factory, a name that feels like paradox and poetry at once. Here, scientists have built machines that mimic the birth of the universe. In reverse, they smash protons into dense metal targets, and from that wreckage, a brief, impossible thing is born. Antiprotons, carried in rings, slowed, cooled, and trapped. They do not explode. They do not flee. For the first time in history, they wait. Imagine trying to catch a snowflake in a hurricane. That is the task here. Antimatter annihilates on contact with matter. To even see it, it must be held apart from everything it could touch. And so the traps are magnetic, electric, perfect in their symmetry. Vacuum chambers protect the particles from even a single air molecule. Inside these chambers, the temperature is near absolute zero. there is no room for error. Every particle caught is a triumph, a moment the universe was asked to pause and did, and yet they do it, not once, but daily. Antiprotons are stored, studied, held for seconds, then minutes, then hours. Sometimes entire atoms of antihydrogen are formed one antiproton, one positron, orbiting in mirrored perfection. They drift in darkness, not glowing, not shining, just being. You are allowed to imagine them, not because you need to, but because they exist. The people here do not shout their discoveries. They whisper them, publish them, peer review them. Their work is not a headline, it is a hymn. Years spent tuning coils, designing traps, perfecting vacuums, and all for particles that could be gone in a blink, if not handled just right. This is not the world of science fiction. It is harder, and in its difficulty, more beautiful. The Alpha experiment, for instance, has managed to trap antihydrogen atoms for longer than 1,000 seconds. In that time, researchers can study how antimatter behaves. Does it fall like matter in Earth's gravity? Does it respond to light the same way? Does it mirror, truly, what we know? Every test is a doorway. Every result, a slow unfolding of truth. And here's something you feel deeply. The scientists are not hunting power. They are not building engines or weapons. They are studying with reverence. This is fundamental physics, the pursuit of understanding, not utility. To know what antimatter is, not what we can make it do. To understand the universe, not only as it shines, but as it almost did not. In these quiet rooms, the universe is peeled back, layer by layer, not broken open, but invited to speak. You pause now in front of a containment fielder device, no bigger than your hand. Inside it, a few dozen positrons hover. Their presence is invisible, but unmistakable. If they touched the walls, they would vanish. So they do not. They remain, held by math and care. You let your imagination drift toward the absurd scale of it. These are particles smaller than atoms, carrying the mirror signature of matter. And yet, to keep them alive, if you can call it that, requires entire buildings, years of design, supercooled systems, all for a flash of existence that may last only moments. But those moments matter. They are evidence that the universe has rules we can follow if we listen. Elsewhere, in facilities like Fermilab and Brookhaven, similar dances play out. Experiments with muons, antiprotons, exotic atoms, each one asking questions about symmetry, decay, interaction. Each one hoping to find a clue not just to antimatter, but to why there is something rather than nothing. You begin to see the work not as technical, but as almost spiritual. A devotion to clarity, to purity of question. These are temples built for wondering. You were struck by this thought. The antimatter we create here is not natural. It does not float freely in the world. It is coaxed, lured, begged into existence. The effort is enormous. The results small in mass, but infinite in implication. And what do we learn? We learn that positrons behave just like electrons, but with reversed charge. We learn that antihydrogen absorbs and emits light just as hydrogen does, with the same spectral lines. We learn that the laws of physics, at their most honest, seem to hold steady even for the mirror. But we also learn how close we are to the edge, how small a difference would need to exist for everything to unravel. A slight asymmetry and all would vanish. A flicker in the laws, and the balance would break. It humbles you, and it fills you with quiet respect for the scientists who dedicate their lives to this. They are not chasing glory, they are chasing precision. They are building ladders to truths so delicate they can only be measured, never held. You wonder now, could we build an antimatter engine? Could we store enough, safely, to power a ship? The answer remains barely no. Not yet, not at this scale. The energy cost to produce antimatter still far outweighs what we get back. The traps are not portable, the risks remain high, but the ideas are here, and the patience, already. We use positrons in medicine. PET scans positron, emission tomography use antimatter to image the body. Hospitals, not stars. The future, in small pieces, has already begun. You see this chapter not as a story of conquest, but of listening. We do not force the universe to reveal itself. We wait, build, refine. We become quieter, more precise, and through that stillness, something answers. You return now to the center of the lab, where nothing moves. The walls are lined with wires, sensors, quiet screens, and in the middle emptiness, a chamber sealed in layers, colder than space. Inside it, a few atoms of antihydrogen hover unseen. They do not glow. They do not speak, but they are there, and that presence, however brief, is enough to change everything. The impossible held for a moment, long enough to measure, long enough to wonder, and you, standing in this cold room, feel warmer for it, because the universe, despite its scale and silence, is willing to answer. If only you ask gently. You've wandered through a universe of vanishing reflections, not to chase answers, but to rest beside the questions that shine quietly in the dark. Antimatter has slipped back into the silence, but you remain a soft survivor of something symmetrical and strange. Sleep now, knowing you are part of a cosmos that chose, ever so gently, to let you be.